Hello, I'm here today to show an example of a DCS operating screen. And what we're looking at here is the screen that the operators on site would interface with when controlling Tabor's combustion optimization system developed in the Griffin AI Toolkit. You'll see here two levels of switches, the first being this larger switch at the top. This is their main switch that allows them to, in one movement, control if the Griffin optimization system is active or inactive. And then below here you see each subsystem has its own individual switch indicating whether that system is currently on in effect and optimizing or if it's off. If we start this, you'll see that there's also connections to the subsystem screens that see the currently implemented bias being calculated by the COS. That's what these yellow values all are here. And then you see the final position of the particular parameter. And then again, you have another indication of what systems are on and off right here. I go back now to the main screen and I switch off the main control, the main permission switch. You'll see that the other switches below the subsystem switches turn to orange. That's meaning that they had been enabled, but there is actually a permissive that's not allowing them to be fully active. That permissive in this case is the Griffin Optimizer main switch. So as soon as that off switch is clicked, the operator can see that the Griffin biases are slowly bleeding out of the system. They're all going to zero, so that they know that the unit is the DCS values and that it's not being affected by Griffin's optimization anymore. The ramp rate at which this occurs is adjustable. We like to keep that slow enough that there's not any ill effect or swing that the unit gets put into, but this is always site by site. Always like to develop these screens in conjunction with the operators and the DCS techs so that they're comfortable with what is going on in each of these screens. You can see that those biases are bleeding out here. Most of them have already reached zero, and then there's also that indication that those loops are off. Then I can very quickly go back and turn the system back on. Immediately, those subsystems that had been missing that permissive go back to active. But what's important is that the actual manipulated variables, the dampers or whatever's being controlled on the unit, don't immediately pop back to what they had been. The system recognizes that the current position was zero bias, and it'll have to go through another optimization cycle to determine the optimal setting for each of those parameters. Again, this is the interface that the operators have. Through a couple of simple clicks, they can activate and deactivate and also see the effects of the combustion optimization system on their unit.